All right, hello and welcome to your 0th lab. We like to start at 0 in computer science, of course. So let's go first to look at the write-up for it. That is here on the course modules page in week 1. Just click on lab 0 and it'll have the write-up, and you're watching this video down here. So click on this write-up and that'll open up this right here. I will eventually let you work in pairs for labs, but not yet. This one has to be completed individually until I say otherwise, okay? So just keep that in mind. And so yeah, here is your 0th lab. It's you're just gonna do a hello world just to get accustomed to the autograder and working on the class server, and then you're going to figure out how to figure out if a number is prime, and then also calculate pi, which is really cool. So yeah, let me show you how to do all of this. This is definitely the easiest lab, so you don't want to waste your dropped lab on this one. So please get started and get it in, okay? So I think before we get to the terminal stuff, what I'd like to do is just get you onto the class server. The very first thing you need to do is install that SSH client. So look at this page, because I've given you a video as well that explains how to get onto the class server. So figure out how to get on there. Either use PuTTY or the SSH command, but you need to get into your account on the class server, okay? And your account is exactly the same username as your class website account, and right now it also has that same password because it's 2 separate accounts, right? So your default password and username are last name all lowercase and an underscore, and then your student ID, and it will ask you to change it the first time you log in, okay? So just get connected, watch this video, and make sure you have a terminal and you're ready, okay? So let me connect now to my own test account. So SSH, the username, at server.lawtonsclass.com. And I'm going to sign in as me. And so get the cow and you're ready. All right, so I am in my home folder on the class server right now. And so let us get started. So if you were not taught the terminal in CSCI 40 and 41, we're required to teach it here at Clovis Community College. So I am sorry if you didn't get it in any of your previous classes, but I'm going to assume knowledge of it. So if you have not heard of it, please yell at me in office hours or on Discord, and I will get you up to speed. And you should also read the Learning the Shell guide in the optional reading page on our Canvas, okay? That'll help you get everything settled. But the gist of it is, for those of us who are also a bit rusty on using the terminal, we are plopped in our home folder, which is the tilde. The real name of that folder is /home/ a folder with your username in it. And then you can see what's there. And let me just get rid of everything. Doesn't matter. So there's all that. It's all gone now. So if you say ls, that shows you what's in your current directory, all the files and folders that are there. I used to have some from previous semester, but I just deleted them all with the rm command, and so now it just doesn't show anything at all. When you type a command, you press enter, right? And so, yeah, now I have nothing here, and I can move around. I can make a folder, like I want to make a labs folder. That is make dir, and so maybe I'll put all my labs in the labs folder. And so now I'm in my home folder. I just made a labs folder inside of that I can like double click on and go inside with the cd command, cd labs. So let's get in there, and again, there's nothing there right now, but now we're ready. Okay, now we're ready to populate it with stuff. So let us get started. I think maybe the first thing I should show you is just editing and compiling a simple C++ program. I'm going to, I guess I'll show you Nano, but really you should be using Vim. Definitely use Vim Tutor and learn how to edit with Vim in a cool way. But let me make just a simple Hello World program just as a test. Maybe I'll make a simple test folder out here, make dir test. And it's 2 dots to go back out. So now I'm back in my home folder. I make it a separate folder called test. Let's go inside of that, and then I'll make a new file in Nano called hello.cpp. So here's my hello world program. Yay. And it's this is the caret symbol. It means control. So if I type Control X, it will exit out of this back to the terminal and save the file. Or it'll ask me if I want to save it, and I say Y for yes. What's the file name? The same one. You just hit enter. And so now I have made a hello.cpp file that I can compile and run. All right. So yeah, that was Nano. You should learn Vim though. It's pretty much the same. Vim hello.cpp. It just looks cooler. And then you can do fancier things. And then yeah, you just save quit, and you have your file ready. And now you want to compile it so that you can run it. So to compile a file, you say G++ standard equals C++ 17. That's a little dash right there. Then you give the name of the file, and then you give -o and what you want it to be compiled into. If you don't use this part, it just be it's compiled into a file called a.out, which we don't like. So always give the -o, right? So G++ standard equals C++ 17. That's the latest and greatest version of the language. Hello.cpp, and then I want it to be compiled into a file that I can run. Let's just call it hello. Okay. So I compiled it. There are no errors. It worked, and so it made this file called just hello that I can run on my terminal with /, the name of the file. So /hello, hit enter, and it runs the program. Okay, so to edit a file, you use Nano or Vim, and to run the program that you compiled after you use G++ to compile it, you can use /. Okay, so that is the terminal and compiling things in a nutshell. Please yell at me, come to office hours. I will be happy to go into more depth on any of this stuff. But that's a good place to start, and hopefully it's all coming back to us. Okay, so yeah, we're going to use standard equals C++ 17 all over the place. The default is an older version of the language that's not as cool. All right, so yeah, let's talk about primality. So the first thing, let me show you how to get the code and all that. So let's go back to the write-up. I've made a fancy command for you on the class server. You just say gimme, and it downloads the starter code for you. Okay, so if you say gimme lab00 at CSCI26, it'll go and find the lab00 assignment, and it will make a lab00 folder in whatever directory you're in. So go where you want this to be saved. So maybe I'll go into my home folder. I made a labs folder for myself. I'll go into there, and this is where I want to do my work. So I'll say gimme lab00 at CSCI26. Hit enter, and it copies it into a new folder. So it used to be empty, and so now I have a lab00 directory. I can go into that with cd, and here are all the fancy files that it made for me. hello.cpp, pi.cpp, all these .h files and things. There's also a make file, okay, which we'll be using. That compiles it for us. Very cool stuff. Yeah, I think you've already changed your password, so we're good there. So yeah, the first thing that you do is just write a hello world program in hello.cpp, okay? And the program has to print exactly hello world, I'm ready for CSCI26, and then a new line, okay? So let me write that incorrectly. So I'm going to show you how to turn it all in. Hello.cpp. So yeah, write a program that outputs the string hello world, I'm ready for CSCI26, followed by a new line. So let me do it wrong. Whee. So I'll show you how that all works later. But yeah, that's the first thing. Yeah, let's do the hello first before we talk about primality. So let's compile and run this, our hello program. You just type what we typed before, because it's the same file name. G++, all that stuff to compile it, and it made a hello file for us. We can run /hello. So get it all nice, and remember to do it correctly. I'm going to show you what the autograder says when it's incorrect, and so that's why I did it wrong. But yeah, that's the first part. And then the second part is the primality stuff. So go ahead and look at the primes.h file. That's where you're going to be implementing the, or that's where the declaration of the isPrime function will be. So here are all the files again. We're going to work with primes.h and primes right now. So here's primes.h. Here's isPrime. That is the function that we're about to implement in the .cpp file. Okay? And it's supposed to return true if the given number is prime, and you know that the number, it's guaranteed to always be greater than or equal to 2. So you don't have to worry about negatives or 1 or anything. Okay? And you just say, you take the number, and you give back true or false based on whether or not it's prime. Okay? So that's what you're going to be implementing. And you're going to implement it in the primes.cpp file. So let me open that. Whee! And so, yeah, here's a stub of the function. It's always returning true right now, but implement it for real and make it return the correct thing. Okay, so that is that. And then I'll show you like the test primes and all that. So you're going to implement this, and you're going to run, like to check if it's working, I've made a test program for you called testprimes.cpp. So let's open that. Here it all is. And so I've made a million little tests for us. And that's just running your function on a bunch of different inputs, making sure that it gives back the right answer for all of them. Sometimes prime, sometimes not prime. Okay, so yeah, get your implementation correct. I'll talk about how to do that, but I've made a makefile for you that will compile everything. So let me look at the makefile with you right now. Here's the makefile. And so we're going to, I guess I could have used it on hello, but whatever. We can say make test primes, and that will compile the runnable test primes program for us. Okay? So I can say make test primes. Ask me if you'd like to know more about makefiles and you didn't learn them before. They're very useful, but this will compile a program for us using a bunch of intermediate files. Very nice. So this just made, among other things, made some compiled versions of all of our libraries and things, but it made the test primes program that we can run, and it runs the tests that I made for you. Whee! And so right now it's just always returning that everything's prime, so you passed some and failed others, so that's why it's doing that. But yeah, that's going to be your strategy. You're going to edit your primes.cpp file, recompile test primes with make test primes, and then rerun the test primes program until you see passed everywhere, or until the due date happens. Okay? So these are the same tests that you're going to be graded on, so that's useful. So that is what you're going to do. Let me show you one way to determine primality, the easiest way probably. It's in your book, actually. If I go to this class, and then which chapter did I said 9.4. So we go to 9.4, factoring in primality testing, aptly named. So here is an algorithm for figuring out if something's prime or not. I guess, is that what I want to do? Yeah, that's the easiest one. It'll say prime or not prime, I guess. You can change this ever so slightly. So, yeah. What you do is you go through every possible factor that you could be having in this number, because every number, it's either prime or it has something that divides into it, right? So you just go through all of them from 2 to n-1 and see if that number evenly divides the original number. If it does, then it's not prime. You found a factor. Otherwise, if you got through all of them, it was prime. Does that make sense? So let me show that to you in Racket. I don't have Dr. Racket for you anymore, but you can install that by yourself if you'd like. There's a fancy graphical editor for Racket that I can show you more about. So let me go back to here. In the code from class, I made you a lecture 1 folder for the first day because we wrote code then. Let me make a lab 00 folder so that you can have this code that I'm writing for primality testing. Primes.racket. And so let me just code this up for you, and you can translate this into C++ after I'm done. So, dun dun dun, like bracket, and then let's make a function called isPrime. Actually, in Racket, you can make cool functions that look like this. Define prime question mark is a number n prime. So what you want to do is you try all the factors, try all the possible factors between 2 and n minus 1. So let me iterate through all of them. Here's a loop in Racket. So here's a for loop for the, I don't know, I goes between 2 and n minus 1. If I say n, it goes up until n minus 1. So for all of those numbers, call them I. See if I divides cleanly into n. If so, the number isn't prime. And then otherwise it is. So let's make it maybe like a variable. Let's say define, was it prime? Let's pretend that it is until we find a counterexample. Okay? So if we ever see a number that divides cleanly into n, so cond, if I divides cleanly into n, what does that mean? Well, you can get the remainder, okay? So hint, use the remainder. That's going to be modulus in C++. So you do, in Racket it's called modulo. So let's do n mod I, get the remainder after dividing n by I, see if it's 0. If this is all equal to 0, then if that is true, in that case, it was not prime. Actually, I don't need to use cond. I can say when. When this is true, do this. I want to set was it prime to false. Okay, and so that's the way you can do it. So when, if it's ever the case that this I divides cleanly into n, which means the remainder was 0, yeah, in that case it was not prime. All right, and then the final value that will return is the was it prime variable, whatever it was, either it's true or false. So if we got through the loop without ever setting this, it'll be true still, and so it really was a prime number. Otherwise, it was false. Okay, that's our prime function. And let me show you it working. So let's say, is it prime 25? That should be false. But 27, that's still false, right? Is 29 prime? Well, we'll see. But yeah, that's what you can do. Racket, prime star racket. Yeah, so yeah, false, false, true. And apparently 29 is prime. So you just try all the possible factors between 2 and n minus 1, and then yeah, see if they were ever true. If they ever, that factor divides cleanly into the original number n. Okay? So that is calculating primes, and this is what you'll implement in C++. You can actually do it a bit faster. You don't need to go all the way up to n minus 1. You can go up to, and your book talks about this, you can go up to the square root of n, because you just want to find the smallest factor that exists. Okay? So that is the algorithm that you can implement in your isPrime function. And that will be the second part of your lab. So that's primality. And then finally, the coolest thing is you can calculate pi by throwing darts at a virtual dartboard. Isn't that cool? So this is going to be done in the pi, the approximate pi function that you're going to write. So here is, back to the starter code. Let's look at pi.h. So I have made a point class that represents a 2D point. It has an x and a y. And then here are some cool things that you can have inside of the point class. You can make a random point with x and y between 0 and 1. We'll talk about that. That's a static method. And then here is the constructor for points, and here is the distance from the origin of a point. Okay, these are things that we'll need to implement. And they're going to use the point class to implement the approximate pi function by giving the number of darts that you want to throw at the dartboard. It's really cool. So with an explanation, it'll make more sense. So let's go to pi.cpp. So here is, I've implemented the constructor, I've implemented the distance from origin, and I've also implemented uniform random points. So you've got the point class ready to go. You just got to use it, okay? And so here is my stub for you to implement the approximate pi function, and you just want to return the right answer once you've calculated it. You're going to get some random points, some uniform random points. You're going to keep on throwing them num darts times, and that will help you calculate pi, okay? So let me show you how this all works. Dun, dun, dun. So definitely read this, but I think I have a slide about it as well. So here's how you calculate pi by throwing darts. It's really, really cool. You just draw a square, a unit square. So it's 2 by 2. Here is the here's our axes. Here's 0, 0. There's the origin. So we drew a square, 2 by 2, and let's draw a radius 1 circle inside of that square. Right? That just ever so slightly touches the edge. It's a radius 1 circle. And so we have a circle and we have a square. And the idea is we can calculate pi by randomly throwing darts within this square. Okay? Imagine that. So 2 by 2 square and a circle of radius 1 inside of it. And now we're going to put on a blindfold and start throwing darts at random spots inside the square. And so think of what these like coordinates would be. This is like negative. Down here it's -1, -1. Here's 1, 1. So these are all the random coordinates that you'd eventually have. And so let's make sure I'm doing that way. Dun, dun, dun. And so I think, yeah, I do it slightly differently here, but that should make enough sense. You'll use this to make a fancier version of what you want to do. Okay, so here is, yeah, I'll get into that in just a second. Sorry, I got ahead of myself. So here is your dartboard, and it just so happens that if you just randomly put on a blindfold and start throwing darts, bam, 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 some of them will hit the circle, some of them won't hit the circle. And that approximates pi, in fact, because what's the odds that it'll hit the circle? It has to do with the area of the circle divided by the area of the whole square. Does that make sense? Like, sometimes you'll hit the circle, sometimes you won't. It has to do with areas, because you got this much area to hit inside the circle. So here's the idea. The number of darts inside the circle, if you divide that by the number of darts that you threw that hit the whole dartboard, that approximates the area of the circle divided by the area of the whole thing, which was the square, right? What's the area of a radius 1 circle? It's pi 1 squared. Pi times 1 squared, that's pi. What's the area of this square? 2 times 2. It's 4. So the ratio of areas is pi over 4. Oh man. So if you throw a bunch of darts and you count how many of them landed inside the circle, and then you divide that by the number of darts you threw based on these areas, you're going to approximate pi over 4. Isn't that crazy? Isn't that super cool? And then if you wanted pi, if you wanted an approximation for pi out of that, you just multiply it by 4. Okay? This gives you an approximation of pi over 4. Just multiply whatever you get by 4, you've got an approximation for pi. Yeah? That's the idea. What we're going to do, though, is we're only going to consider the first quadrant. That's what my random function is doing. It's only giving you a random point within the first quadrant, and that still works out, okay? So the ratio still holds exactly the same. It's still pi over 4, okay? That's the idea. So yeah, just see if your dart landed within the circle, which means it has the distance from the origin is less than 1, or if it landed outside the circle, the distance from the origin was greater than 1. Does that make sense? That's the idea. So that's what you're going to be programming. I'm going to be using all this stuff. So throw a bunch of darts, look at their distance from the origin, and that will tell you if it was inside or outside of the circle. And then use that to find your approximation of pi. Okay, does that make sense? That is the idea. It's a really cool way to approximate pi. It actually converges very, very slowly. It's not too nice, but it's good enough for us. All right, so that's the last part of your lab that you're going to be implementing. So one thing that you might not have seen before that I don't teach in my 40 or 41 is static methods, okay? And you're going to be using one of those. Boop. This is a static method, uniform random point. It creates a point when you don't have one yet. It makes a point for you, returns a point. And this, static methods, they belong to the class itself. They don't belong to any object of the class. So it makes no sense, like you don't use dot with an existing point. To make a uniform random point, you say the name of the class, colon, colon, the name of the static method to call it. So what you're going to do is to make a uniform random point, you're going to say point, colon, colon, uniform random point. And that will make for you a point, okay? So you can be like point P. That's how you call a static method, okay? It equals that. And so you see how there's no object, there's no dot, because it's making the point for you. It's part of the class itself. Okay, that's how you use a static method. So you'll need that. And then that's really it. That's your lab, all the different parts. Not too bad, just takes a while to explain the first time. So what you'll do to turn in your lab, go inside of your implementation directory, and you're going to turn in only your the stuff that you implemented, okay? The CPP files. So I wrote this in the write-up as well. So, dun, dun, dun. You're going to say turn in lab 00 at CSCI26, and then space separated all the files that you worked on. So turn in lab 00 at CSCI26, and then hello.cpp, primes.cpp, and pi.cpp. Yeah. And then you'll hit enter, and it will start grading. So one thing that I need to do right now is make the auto grader happy. Boop. So let me tell it that this lab exists right now. Don't worry about that. That was just something I needed to do so that I can actually turn it in now. Otherwise, it will give me an error. So on your end, you just say this line magically, hit enter, and if all goes well, it'll look like this. So it'll wait for the autograder to start, and it's like, okay, you can press Control-C at any time to close the window or to close this auto-grading program. It will just grade in the background, not a big deal. But if you keep it open, it'll tell you, like, oh, started grading, finished grading. You can now look at your grade using the terminal. You can use the view grades command, or you could go to the class website, and it also got uploaded there, okay? And then it says auto grading is complete. Please press Control-C to close the submission program. Bam. Control-C, now we're back at our terminal. And we could either use view grades, view-grades, hit enter, and then you give, these are numbers, which thing you want to look at. There will only be one for you, but I'll say 0. Probably be 0 for you too. 0 and hit enter, because that's the lab that I just submitted. I want to look at my grade, hit enter, and then you can like use the arrows to look at your grade and things like that. So I got 6.5 out of 27 right now. Oh man. Scroll down, press Q to stop looking at your grade. So that's how you can look at it on the terminal, but it's also getting uploaded to the class website. So if you go and log in on the class website, you can go to the lab grades, click, and then you can look at it in a prettier form. Okay, I encourage you to look at it on the website. Because it highlights what went wrong. So like here is the Hello World program that I did incorrectly. Here is like what the difference was. Here's your stuff on the left. Here's the expected stuff on the right. Yeah, and so that's why you got a 0. And then here's all the autograder output for the other tests. Okay, you get some credit with the default implementation of isPrime. You're welcome. But yeah, that's your score, and yeah, that's how you submit and make it all work. So yeah, that's all that I wanted to show you there. You can submit as much as you want up until the due date. So just keep on retrying and just rerunning this turn-in command with all the files, and then you'll be good to go. Okay? So yeah, up until the due date, keep on turning it in, and that is your first lab. All right? I really want to encourage you to never just submit and think that you got it right. Okay? You will almost always be unpleasantly surprised. Maybe you did something slightly wrong. So always go and check your grade after you submit. Okay? Definitely do that. But that is your first lab. Yell at me on Discord if anything is going wrong, if you're unable to connect or anything like that. I want to make sure that everybody is able to get started on this. Okay, so that's your first lab. It's probably the most explanation that I'm going to give for the labs, but I think it was worth it. So thanks for watching, and I'll see you next week.